driving the base for these transistors and these bucking coils is very important, because the loading characteristics are a little unusual. You've got to be very careful how you drive the base. And in relation to my last video, which is playing with asymmetrical regauging, I made a few important notations, and I'd like to go forth and make another. I've currently got a 10 ohm load going from the positive power supply to the joint collectors for the Darlington pair, or rather to the collector of the Darlington transistor, which is feeding the base of the main transistor. So typically you'd have the positive of the power supply going to the primary and then going to the collector, and then both collectors. But in this instance I found I was getting a cleaner response by not having the base drive run through the transformer. So instead I'm running the base of the main transistor driver straight from the positive signal, straight from the positive input through an appropriate resistor, which I vary between about 10 and 30 ohms. Currently got a 10 ohm in there, and did for the last video. But this creates a strange threshold issue. So currently at 40 volts, 250 milliamps in, and about that much light. But as I drop it down to 35 volts and back up, that's the difference between 35 volts and 40 volts. And that is due to the appropriate, or basically to a drive transistor running effectively. So simply we can modify the resistance on either coil to do that, and in this instance we are actually doing it on both, which is unnecessary. So I just thought I'd note this before I go and start putting some positive voltages on my shorting coil. So yeah, there we go. Hope you watched my last video. This is still on the same night. I figured it wouldn't take long, so I'd just try it. Jump straight into the next experiment. I've thrown all the other stuff off to the side, so what I have is the 80 turn primary, 100 turn secondary, which is going through a diode to the light globes via the relaxation energy, and I've still got the 300 turn shorting coil. So I'm going to turn on, this is for the primary, this is the power for the primary. We have 30 volts and about 50 milliamps producing some light. But that's not all. I should note we also have 30 volts, which is being switched by my unusual opto-isolator through the shorting coil. So we're also using the shorting coil as a primary, as a second primary. And that's the old shorting coil control. So as you see on the yellow trace, we now have the usual input and our adjustable second input through the shorting coil. So we can have a play with this and see what effect it has. Fairly interesting, but it remains to be seen if that's meaningful. And I'm currently unable to change the voltage going across the shorting coil. You can clearly see the difference that 300 turns versus 80 turns makes. You've got the 80 turns and the 300 turns. Significant difference to the voltage. but basically I run out of power supplies. This homemade one is being used to run my opto-isolator circuits. This transformer up here is being used to run my drive circuits, both for the shorting coil, the output coil, and the primary. And this power supply is obviously being used for the main primary coil input. So yeah, this is the most energy inefficient free energy machine you've ever seen. But it is producing some very curious results. So, and it's also quite a lot of fun to play with, but we're going to ignore that aspect in the interests of producing some useful science. Now, I'm paying for this because that's going into the primary, and I'm also paying for this because it's going into the shorting coil. But when I superimpose them both, you get greater light. You get more energy output, which is odd. So there's the globe, there's my adjustment, and I'm going to superimpose the two thusly and have a look at the effect that has. Now when I do that, it makes almost no difference to the primary input, and it remains to be seen what difference it makes to the secondary input, but I suspect that one does go up a little. So obviously this is currently 5 minutes past 3 in the morning, and I'm looking forward to dinner. So yeah, there's a few possible areas for inaccuracies here, but it does look quite interesting. So yeah, thank you.